Hi everyone, I'm Leo Drakopoulos and I'm a solutions architect at AWS. Today I'm going to speak to you about serverless API authentication for your HTTP APIs on AWS. So what can you expect from this session? So you can expect that we'll dive into the technical details and also that you need to be slightly familiar with concepts like OAuth 2.0 and JWT. Also some familiarity with Amazon API Gateway. Moreover, you'll learn how to implement different types of authorization and authentication for HTTP APIs on Amazon API Gateway. In addition, we have two different flavors of APIs on Amazon API Gateway, HTTP APIs and REST APIs. So we're gonna focus on authentication differences between the two. And last but not least, we're gonna learn how to implement mutual TLS authentication on Amazon API Gateway. So previously I mentioned that we have two flavors of APIs on Amazon API Gateway, REST APIs and HTTP APIs. So let's learn more about HTTP APIs and how those two differ. So HTTP APIs is the newest flavor of Amazon API Gateway, and generally it will help you improve on cost efficiencies, reduce application latency, and also we did some sort of revamp on developer experience, so you should be able to configure HTTP APIs easier and faster. But this session is all about controlling and managing access. So let's have a look on the different approaches to control and manage access with HTTP APIs on Amazon API Gateway. So the first one is JWT authorizers. And with those authorizers, you can expect that they will help to implement auth 2.0 flows and use JWT tokens. Then we have Lambda authorizers. And with this approach, we're going to leverage Lambda functions to implement your authentication flow. We have also IAM authorization, and this is where you will use IAM credentials to implement your authentication flow. And last, we have mutual TLS authentication. This is where you will provide a client certificate for your authentication flow. So we've introduced those different methods. Before we have a deeper dive on all those different methods, let's examine where it's appropriate to use each one of those methods and why. So the JWT authorizer, it will generally allow you to support auth 2 flows like implicit grant or authorization code grant with minimal coding. So mainly you'll have to configure things within Amazon API Gateway rather than code everything yourselves. With Lambda authorizers, you can leverage a Lambda function for your authorization flow. So you have complete control on how this flow will look because you can code everything within your Lambda function. So if you want to have this level of control, this approach is very good for that option. In terms of IAM authorization, you will use AWS IAM credentials for authentication. And for mutual TLS authentication, it's all about providing a client certificate authentication. So in many cases, if you want to support a regulatory requirement, like for example, open banking, which is a standard in the financial services industry, those kind of regulatory standards mandate that you set up mutual TLS on your API endpoints. So if that's the case, then mTLS is a very good option here. So now let's dive deep on all those different authorization methods. So let's start with JWT authorizers. So what I'm gonna do first is describe the authentication flow, and then I'm gonna provide a demo to bring everything together. Okay, so let's just start with the actual JWT authorizer flow. So the first step is send a request to an identity provider. And by sending a request, this means I'll probably enter my username and password. Now, if that username and password, if I'm authenticated successfully from the identity provider, then I'll get back some JWT tokens. And now those JWT tokens are on the client. Next, the client will make an HTTPS request with those JWT tokens to Amazon API Gateway. And normally, this request will include those tokens into the authorization header. What will happen next is API Gateway will validate those tokens. And those tokens might also include some custom scopes, right? So provided that validation is successful, then the request will be authorized. And of course, you can use those custom scopes into the JWT token for further downstream authorization decisions. So that's the flow roughly for JWT authorizers. Let's have a look in the demo. So the demo that you're gonna see in a bit will have two differences from the actual flow that I presented before. So first of all, for an identity provider, I'm just gonna use an AWS service. And that service is Amazon Cognito. So Amazon Cognito also offers a hosted UI where I can enter my username and password. And Cognito being an identity provider itself, if I'm successfully authenticated with Amazon Cognito, I'll get back some JWT tokens. In addition, instead of using an arbitrary backend service, instead I'm gonna use a Lambda function. And this Lambda function, if successfully invoked, it will just add two numbers. So we'll have a very simple Lambda function there to perform an addition, provided that the request is authorized. So let's jump into the demo, and the demo is going to start with showing you a few different configurations within Amazon Cognito.
So what you see here is the Cognito user pool that I've created for my demo. And with this user pool, I've created a user that I'll use later to sign into my application. Furthermore, I've made more configurations in this user pool. So first, I've created a callback URL. This is a Postman callback. So this is where I'm going to get back the tokens after a successful sign-in. I have allowed different auth flows. I'm going to focus on implicit grant on this demo. Some allowed auth scopes as well, like for example, email. And also I have a hosted UI. This is where I can enter my username and password in order to get back the access tokens to sign into my application. Now what you see here is the API Gateway console. And in this API, I've configured many different routes, like you see here, add, multiply, and subtract. For the add route, I've configured a JWT type of authorization. The identity source is the authorization header. This is where I'm gonna pass the tokens to get authenticated. The issuer and identity provider is Cognito, which I configured in the previous step. And also I'm able here to configure different authorization scopes to make more downstream auth decisions. I have the ability to configure those custom auth scopes in Cognito if I want to, but in this instance, I have not. Now on the next screen, you can see Postman. And this is where I'm gonna send a request to my HTTP API endpoint. This is the add route as mentioned before. Now you can see I have an auth2 type authorization flow and the access token is not populated. So what I'm expecting now is when I send a request is that I'm gonna get an unauthorized message as you see here. That's something we expected. So let's get an access token. So as I mentioned before, I configured the implicit grant flow. I have my callback URL. I have my auth URL. This is the URL to launch my hosted UI. And I'm going to request a token. So the hosted UI launches. So right now I'm going to sign in to get back the access tokens. As you can see here, I'm getting 2 tokens, an access token and an ID token. That's what happens in the implicit grant OAuth flow with Cognito. And I'm going to use the access token. And now I'm going to send the request. So what I'm expecting now with the populated access token is that I'm going to get authenticated and I'm going to get a successful result. As you can see, the addition was successful. I managed to add 2 numbers through my HTTP API. And this concludes the JWT authorizers demo. Let's proceed to learn more about Lambda authorizers.
Okay, hope you enjoyed the demo. So let's now jump into Lambda authorizers. I'm gonna follow the same approach where I'm gonna first show you the Lambda authorizers authentication flow and present a few different details around this particular authorization method. And then I'm gonna bring again everything together with a demo. So a Lambda authorizer, in order to invoke a Lambda authorizer, you need to provide that with an event payload. And as you can see in this slide here, we have 2 different versions of event payloads. So version 1 of event payload is provides a compatibility event format with the REST API Lambda authorizers. So remember I told you there are 2 different versions of APIs that you can use on API Gateway, REST and HTTPI. So here we have REST API Lambda authorizers. And with version 1, what you can do is, if you are already users of the REST API Lambda authorizers, since there is compatibility between the 2, you can get those Lambda authorizers and reuse them with HTTP APIs. For version 2 event payload format, it is very similar with version 1, but there are a few breaking changes there. So if you try to reuse existing REST API Lambda authorizers with version 2 event payload format, you might observe some breaking changes there. So it's important where you're creating an authorizer using the AWS CLI, the SDK or CloudFormation, you need to specify the event payload version. And you can do that by using the authorizer payload format version field, as you see here. Now we discussed what we will use as an event payload. Let's now see the different versions on the response format. So as you can imagine, the version 1 response format is again compatible with REST API Lambda authorizers. And what you'll get back in this particular response format is an IAM policy. Now, if that IAM policy allows for an HTTP API endpoint to be invoked, then your request will be authorized. The version 2 Lambda response format is slightly different. So it can either return a Boolean value or again an IAM policy. And the Boolean or else simple response format, as we call it, there is a true or false is authorized decision, and you can also pass some information within the context object. So let's now examine how this flow works. So the first step is again to send an HTTPS request to Amazon API Gateway. And also within that request, you need to send whatever the Lambda authorizer is expecting. A very common thing that you would normally send is again a token into the authorization header. Then what will happen is a version 1 or a version 2 event payload will be fed to the Lambda authorizer. the Lambda authorizer will execute the code you've written, and it will return a Boolean, simple, or an IAM policy response. So if the Boolean value is true or the IAM policy allows for that HTTP API endpoint to be invoked, then your request will be authorized and you'll be able to call the backend service. So now let's have a look at the demo, and let's introduce the demo first. So as you can see here, the demo you see immediately after, I will first give the Lambda authorizer a version 2 event payload. I'm gonna get back a Boolean response. And instead again of using an arbitrary backend service, I'm just gonna use a Lambda function where it just subtracts two numbers. So let's have a look in this demo.
I'm back into API Gateway, and more specifically, I'm gonna work with the subtract route. And I have configured a Lambda authorizer. The authorization logic is implemented by a Lambda function. The payload format version is 2.0. The response mode is simple. And I'm gonna pass my token into the authorization header. In many cases, it's very useful to implement a cache behavior as well, so that you don't invoke a Lambda function every time you want to make an authorization decision. Furthermore, here we see the Lambda code, and more specifically, we're saying that if the authorization header has a value of secret token, then authorize this request. We can also pass some additional info in the response in the context object. Furthermore, now we're gonna make a request using Postman. So it's, as you can see, the subtract route. And since I have not populated the value into the authorization header, I'm expecting that when I send this request, it's not gonna be authenticated. As you can see, I'm getting the result I expected. So for now, I'm just gonna add the secret token value into the authorization header and send the request again. The request is now authenticated and I'm getting back the desired result. So this concludes the demo for Lambda authorizers. Let's now have a look into IAM authorization.
Okay, I hope you enjoyed this demo. Let's now have a closer look to IAM authorization. And let's have a closer look to the flow more specifically. So again, the flow starts with an HTTPS request. For that request though to be authorized, you need to have AWS credentials on the client. And more specifically, you need to sign those AWS credentials with signature v4. Signature v4 is nothing else from the authentication process to make requests to AWS via HTTP. And to be able to sign those requests, and your AWS credentials, within the SDKs, we provide you all the tools for you to be able to do that. If you're not using the AWS SDKs though, we provide you the process in our documentation to be able to sign those AWS credentials with signature v4. The next step, of course, is Amazon API Gateway to validate that signature. And what Amazon Gateway will also do is make an IAM policy evaluation. So those AWS credentials have an IAM policy attached, and what Amazon API Gateway will check if that IAM policy allows for an HTTP API endpoint to be invoked. If that's the case, then this request will be authenticated and the backend service will be invoked. An important thing to note here is that it is not best practice to use static IAM credentials, but instead it's best practice to use temporary IAM credentials. And that's because those expire after a certain period of time, and that's way more secure. So for you to obtain temporary IAM credentials, There are many ways to do that, but one way that many of our customers is using and are implementing is using Cognito federated identities. So what Cognito federated identities will do is federate an identity from an identity provider and exchange that for AWS temporary credentials. So let's move forward to the last section of our presentation, and let's learn more about HTTP APIs and mutual TLS. Again, I'm going to present the flow, and then I'm going to wrap it up with a demo. So the first step of this authentication flow is sending an HTTPS request, but including the client certificate. And the next step is for Amazon API Gateway to validate this client certificate. So what you do there in order to have this validation is you upload the public key certificate of a certification authority to a nominated S3 bucket. And then you configure the Amazon API Gateway to be able to essentially point to that S3 bucket with a public key of the certificate authority. So in that way, we can validate the client certificates. And after the validation occurs, this doesn't mean that you cannot reuse all the other authentication methods that we've presented before. So you can have mutual TLS, and at the same time, you can have AWS IAM authorization, you can use Lambda authorizers, or you can use JWT authorizers with the identity provider of your choice. So provided that the client certificate is validated and the further authentication and authorization is successful, then this request will be authorized. And you can call the backend service. So let's have a look now on the demo itself. So two clarifications on what you're about to see is that first, within the mutual TLS authentication demo, I'm again going to use the Lambda authorization method. I'm going to use the same exact Lambda authorizer that I used previously during the Lambda authorization. And in addition, I'm also going to use a Lambda function as a backend service. And again, I'm going to subtract two numbers. So it's a very simple Lambda function. So provided that the request is authorized, this Lambda function will be invoked. So let's jump into the demo now.
We're into the API Gateway console, and as you can see here, we have configured a custom domain name, and we have enabled mutual TLS on that. In addition, we have uploaded the public key certificate of an existing certificate authority into S3. Let's click Edit and have a closer look on that. So first, you can see here that I have enabled mutual TLS. I have populated the S3 URI of my public key certificate. And also would recommend that you enable versioning on that bucket that you have uploaded your public key certificate, so that if you want to use a different version of that public key, all you need to do is populate the S3 version ID there. I'm going to click cancel for now, but if you configured everything from scratch, it would take about a minute for the mTLS status to be available. Let's have a look on API mappings. What I've done here is that I have actually mapped my custom domain name to my HTTP API. So let's have a look on those routes of this HTTP API. You can see here that I have different routes, and if I go to my authorization part of my HTTP API, you can see the routes that I've used before, but more specifically, I'm gonna work with the subtract route here, and I've enabled the Lambda authorization method for that. Having mTLS enabled doesn't mean that you cannot use the existing authorization methods that we've discussed before. So what you see here is Amazon Certificate Manager, And within the ACM service, what we've done is create a private certificate authority. So if you wanted a private CA for your mTLS efforts, you can actually use ACM. And to get the public certificate of that private CA, you can go to get CA and grab this .pem file if you want to. As you can imagine, this is very easy to integrate with HTTP APIs. All you need to do is just upload this .pem file to your S3 bucket that you've nominated into your S3 URI into the configuration for mTLS. Now let's test this HTTP API. And what we're going to do is use the command line and do a curl to my custom domain name, to the subtract route, and attempt to make subtraction of two numbers. You can see here that I'm only passing an authorization header and I'm not passing the client certificate in this request. So as we were expecting, since I'm not passing the client certificate, I'm getting back an error. So I'm not authenticated to make that request. And that's normal because we have enabled mTLS on that endpoint. Now let's do the same thing, but by passing the client certificate. And as I execute that, I'm expecting to get a valid result. So as you can see here, I'm getting back the result of subtracting two numbers. And that's a result from my API. Now this concludes the mTLS demo. Let's have a wrap up of all the things that we've discussed so far.
Okay, perfect. Hope you enjoyed the demo. So let's wrap up everything now, the entire presentation, within these 3 bullet points. So first of all, I just want to reiterate again that just by using HTTP APIs, you can achieve many efficiencies, and those efficiencies are relating to improved cost, improved performance for your APIs, and generally better usability. We focused a lot on this part within this presentation, but again, HTTP APIs offer many flexible ways of authentication and authorization. And the different ways that we've examined are JWT authorizers, Lambda authorizers, IAM authorization, and mutual TLS authentication. And we saw demos for JWT, Lambda, and mTLS. And in addition, I just want to raise again the point that if you're existing users of Amazon API Gateway and you've built your Lambda authorizers with REST APIs, then there is compatibility between REST and HTTP APIs, so you can port your Lambda authorizers and reuse those with HTTP APIs. So that concludes the entire presentation. I want to thank you very much for sitting through it, and hope you enjoyed it and hope that it will help you for your future projects. So thank you again, and also please don't forget to complete the session survey.